Okay, in this video, we will be using load interval diagrams and cascade diagrams in order to determine minimum fresh, minimum waste, and maximum recycle for our given problem right here. So we have two sources and two sinks. Source 1, flow rate 6, maximum fraction is 0.5, so we can easily calculate the load impurity. Simply 6 times 0.5, and we would get 3. Likewise, for the second column, 2.5 times 1.3, and we would get 3.25. Now this is an important note that this column right here has to be in ascending order for our sources and our sinks. Right now, it's in ascending order. We were lucky. It was 3 and 3.25. However, if this was a 3 and this was a 3.25, we would need to rewrite our table right here, where this would be our 1 and this would be our 2. It's very important that this has to be in ascending order. So now we'll do our cumulative load. So the first one is the same, 3. And it's cumulative, so you say 3 plus 3.25. So you get 6.25. Now we do our sinks. 4.5 times 0.1, we would get 0.45. Likewise, 2.5 times 0.3, and we would get 0.75. Again, we were lucky. It's in ascending order. Had it not been, we would need to rewrite. So let's just do our cumulative. So first one's the same, 0.45, and next we add 0.45 plus 0.75, and we would get 1.2. And so after we construct this table right here, we can now create a load interval diagram. And so our load MK is based off of this, but we need to make it in ascending order off of everything. So we don't even care if this is a sink or this is a source. We just see the lowest number and we write. Lowest is a 0.45, so we write 0.45. Second lowest is a 1.2, so we write 1.2. Third lowest is a 3, we write 3. And the greatest, or the fourth lowest, is a 6.25. 6.25. And one more. This line right here, we can call it a 0. And so now we will go to sources. So the first source is a 3. So we start at the 0 and go all the way down to 3. And we correspond this line right here to this value, 0.5. So we can call it y1 is equal to 0.5. Next, we use the 6.25. So we start at the 3 and go down to 6.25. This right here will correspond to 1.3. So we can call it y2 is equal to 1.3. So now we need to calculate this, our source flow per interval. And so that's a formula that we need to use. So for the first one right here, we say 0.45 minus 0. 0.45 minus 0 divided by the arrow. The arrow right here is a 0.5. So divided by 0.5, and we would get 0.9. So we write down 0.9 right here, and we do something very similar for the rest of the numbers. So next one is 1.2. 1.2 minus 0.45 divided by our 0.5, and we would get 1.5. And so we would do the same thing, 3 minus 1.2 divided by 0.5, and we would get 3.6. Okay, the next one right here is a little bit different because, see, the arrow stops for y1, and we have to use y2 arrow. So we say 6.25 minus 3 divided by 1.3. 1.3, and we would get 2.5. Next, we will use our sinks. Same procedure. So the lowest sink is a 0.45. So you start at the 0 and go down to 0.45. And this corresponds to Z1, which is equal to 0.1. Z1 is 0.1. Next, we go from 0.45 to 1.2. So 0.45 to 1.2. The 1.2 comes from here. So we're done with sources, now we're doing sinks. So you can kind of ignore this piece. And so we can call this Z2 is equal to 0.3. And we do pretty much the exact same thing. So 0.45 minus 0 divided by 0.1, and we would get 4.5. And we would get 4.5. Likewise, 1.2 minus 0.45 divided by 0.3, new arrow, and we would get 2.5. There's no arrows here, so they become 0, 0. And now we will use a cascade diagram. And so for the cascade diagram, we're going to copy our sources and our sinks. So 0.9, 1.5, 3.6, 2.5. So let's do that first. So we have a 0.9, 1.5, 3.6, and 2.5. And those were our sources. And now we do the same thing for sinks. So 4.5, 2.5, 0, 0. 4.5, 2.5, 0, 0. And so just starting out with a cascade diagram, you call the top, you say 0. When we use, this is a revised cascade diagram. Once we fix everything, then we can get a revised cascade diagram where this will no longer be a 0. And so the next piece is to calculate this value for this arrow, this value for this arrow, this value for this arrow, and this value for this arrow. And it's pretty simple. So you say 0, 0 plus 0.9, 0.9 minus 4.5, and this will equal negative 3.6. Negative 3.6 corresponds to this arrow right here. Next, you say you continue the negative 3.6. So negative 3.6 plus 1.5 minus 2.5. So plus 1.5 minus 2.5, and this right here will equal negative 4.6. Likewise, exact same procedure. Negative 4.6 plus 3.6 minus 0, and we would get negative 1 for this arrow. Likewise, negative 1 plus 2.5 minus 0, and we would get 1.5, a positive number. Okay, so now in order to create this revised cascade diagram, you check out of these four numbers, what number is the lowest? The number that's the lowest is this one right here, negative 4.6. And so our very top value, 0, will now actually be positive 4.6. You're doing this in order to make this value here 0. And you can say, actually, let me clear this up a little bit. This is a 1, 2, 3, 4. And so you can say that your pinch point will be between the interval 2 and 3. And so let's finish this up so we can answer this question, and then we can kind of clear up what we're doing. So we're pretty much doing the exact same thing. The only difference is that this 0 is a 4.6 and you're continuing the process. So like for example, 0.9 is going to be the same, 1.5 is going to be the same, 3.6 is going to be the same, 2.5 is going to be the same, our intervals, and the next one, 4.5 same, 2.5 same, 0, 0. And so there is one big difference. So this is a negative 3.6. Instead, you add 4.6. And so now we can do the slight so small difference. And that involves calculating these arrows right here. And so now you would say 4.6 plus 0.9 minus 4.5, and you would get simply a 1. Simply, you're taking a negative 3.6 and adding 4.6. Likewise, negative 4.6 plus 4.6, and you would get 0. Negative 1 plus 4.6, you would get 3.6. And finally, 1.5 plus 4.6, and you would get 6.1. Now let's go back to our original question. We want to determine minimum fresh, minimum waste, and maximum recycle. And using this cascade diagram, using this revised cascade diagram, we can actually do so. So this value right here will be our minimum fresh. And the units would be kilograms per second, same units that we had earlier. And the minimum waste is the bottom part. So 6.1 is the minimum waste. So minimum waste, and same units, kilograms per seconds. And we want to calculate maximum recycle. And for maximum recycle, you add up the sinks, 4.5, 2.5. So let me write this down. Max recycle is 4.5 plus 2.5, our sinks, 4.5, 2.5, minus the minimum fresh. Minimum fresh, we know, is 4.6. So 4.6, and we would get 2.4. And this is going to be our maximum recycle. And so I just typed this up. Minimum fresh was our 4.6. our minimum waste was our 6.1, and our maximum recycle was 2.4. And that's all you need to do to calculate minimum fresh, minimum waste, and maximum recycle using a load interval diagram and a cascade diagram.